Okay, I will wait for a few more minutes so that people can join. Hi everyone. Uh, so I think we can start now. So I think all of you have got a notification regarding the exam format. So I have just opened this tab where this notification tab here in the announcement. So where scroll down, you will find exam format 2024. So and when you click on this one, you can find your course. Just type the joy of using Python. So it's a 12-week course and it will be online computer based. So your exams are going to be computer based and all other like necessary things that you have to take care of is written here. Like you have to take a photo ID, all these things. And okay, so computer based. So here you can see the question on the computer and the answer will have to be entered type or it may include multiple choice, filling blanks, etc. type, etc. And also like okay, on screen calculator demo. So if there are some questions which will require this calculator, so they will also provide that. And here you can see how it will look like. So please go through this one. And okay, so just on to share this thing. I think now we can start. So go through this, read this carefully, and uh, practice on calculators if you need. So just go through it once, huh? Okay. So having said that, now we will start with our regular discussion. Okay. So like this is the last week of this code. So I just wanted to ask one thing. Like in the last tutorial, like many of you had this problem of does anybody have any problem with this web page driver, this Chrome driver? Okay, if not, then let's continue with this week content. So in this week, uh, like I'm going to talk about page rank algorithm that Google uses to find the pages based on your keywords that you type, and then uh, a little bit about collaged conjecture. Okay, and I think we have already talked about network X, which it will network X, and it's like how you can draw different kind of graphs using network X and do the uh, net networks. Okay, so let us start with our first question for today. So the first question is in wave graph on which we perform Google page ranking. So if you have a web page uh, and it is there on the internet, so Google, if you search something related to that is related to your whatever is there in your web page, so Google try to find it, right? But how it does that? So it is it does some sorting algorithm, something based on whatever. Uh, so it does it like this, like if your if the link of your web page is mentioned on some other web page, so it actually like it's called hyperlink. So once somebody click on that, and so it is counted like a edge. like just like in your network. So let's say this is the web page one web page, this is two web page, this is three, and they are both are connected due to some, let's say, hyperlink. So once somebody click here, so it landed on this page. So it is like that. Okay. Now, so the question is related to that. So how does Google does it? So the options are web pages are the nodes and hyperlinks are the edges. Hyperlinks are the nodes and web pages are the edges. Both hyperlinks and web pages are the nodes. Both hyperlink and web pages are the edges. So, uh, uh, so what do you think? Which option will be correct? Yes, Priyanshi Shukla is saying it's A. Is correct. Because web pages are the nodes and the hyperlinks. Okay, these are the nodes. These are the web pages. These are the nodes. If you want to go here from here to here, you have to use the hyperlink, and that's why the web pages are the nodes and the hyperlinks are the edges between two nodes. Okay, so the option is correct. And the next question is so now the question is if let's say my node, this node is connected with this node and this node, so there are different connections to the other nodes. Now think about it. So how do you know which which node you want to go next when you are okay? So when you want to select on which node you want to go, so how you are gonna do it? So for that, uh, in this rank page algorithm, do a random motion, okay? And the random motion uh, it does not give any weightage to any node, like from here to here or here to here. So it is completely random. So maybe I can draw it. So let's say there is a node and there is another node and there is another node. But you want to go from here to here and or here to here. So the choice, like you will go to node one or two, it's random. So random meaning like here, because there are only two nodes, so the probability will be half. But it's the same thing. For if there are large number of nodes, so the probability will be 1 by n. If there are n number of nodes. Okay. So the correct so the correct one will be okay. Now I just showed I draw arrow from one node to another, and that means what I'm saying, like if okay, the random motion is done. Like okay, I have selected that like I will go to this node randomly. Now, so now you think about this question. So here what I'm asking, did this things back in like back this would be in your mind, whatever I told you just before. Now think about this question. In the page rank algorithm on a directed network. So a directed network has some edges coming out or going in. So this is what a directed network is. We randomly move from one node to other node. Okay. So the options are a random node which is pointing to A, or random node which A is pointing to. So there is difference between the options A and B. One is so there is one node which is pointing to A, but then there is another thing which is pointing to which A is pointing to means to the other node. And then the option C is a random node out of all those nodes which are either pointing to A or the node which A is pointing to, or none of the above. So it's I think Arun Kumar had said it's option B. So he is correct actually, and it's option B because here in the direct in the it's in a directed network, what happens because there are either arrows coming into a node, or arrows are going out. So if we want to go from one node to other, we have to follow the arrow. So going out to where? And that's why the option B is correct. A random node which is pointing, a random node which A is pointing to. So means we are at we are at a node A, and we want to go at some other node. So we have to follow the arrow. That's it. So option B is correct. Now option C is which of the following statement chooses a chooses sorry, there should be S or whatever. Which of the following statements choose a random node from a graph G? That means we want to choose a node. Means like, let's say, let me say something with you. What have you done? Let's say import network X as an X. Okay. Now what we are doing? The question is a random dot size. So let us import the random also. Import random. Now what we are going to do? We are going to make a graph. So we will say graph G is equal to nx dot graph. Okay. Now what we will do? We will add node. Add add node from. We will use this function, and then we will pass a list 1, 2, 3, 4, and 5. If there are 5 nodes, let us print if there in really 5 nodes. So g dot node, and it should give us the 1, 2, 3, 4, 5. Okay, there are 5 nodes. Now we are going to select some node. Now if I ask, okay, now if I ask what is the probability of, okay, no probability, nothing. I just wanted to ask if somebody wants to choose a number from this list, 1, 2, 3, 4, 5. So what is the probability he's going to choose 3? Okay, Nutan Gupta. Yes, I will show that. Okay, wait for a minute. 1 by 5. Yes, Priyanshi is totally correct. It's 1 by 5 because there are 5 numbers. You are selecting one. So it's just a simple probability question. The probability is 20%. In other words, 1 by 5. Right? Okay, if that's so. So now, okay, now you know this. Like you know how you can okay, how you have calculated this probability, um, like 1 by 5. So it's like that we know. Okay, we are going to select randomly. Then the chances of selecting 3 is 1 by 5. Now, how you do it in Python? Does anybody remember? Okay, does anybody remember it? How we select uh, a random number from a list? Okay, I can show you the question. So here is the question. If it gives you some idea. Yeah, option C is correct. Yes, that's right. Because uh, and I think if you recall, when we when we when we learned about this random function, so we learned that there are a random dot choice function which selects a particular number from a given list randomly. Okay, so this is how we are going to do it here also. We know like g dot nodes is giving us a list. So what we can do for selecting a random number, just print g dot nodes. Okay, now what we have to do, we have to say like random and then call the module random. Then we have to call the module choice and then we are going to give us the choice uh, from a node list. So g dot node. And okay, now it's very intuitive.
Sorry, excuse me.
Oh, sorry. I should say this tab. Yeah, thanks. So here you see, first we noticed like g dot nodes will give us a uh, so g dot nodes will give us uh, a list. Now from that list, if we want to select something, we have to just call the random function and use the choice module, right? Okay. So if we run this, okay. Okay, we have to, I think, let's print what is the type of thing that is written here. Type X. So the type, like whatever this node is returning, this list, whatever we are saying, it's the class actually. So we have to convert it back to a list, right? So the correct thing will be to convert whatever is coming out of from g dot node to a list. Now, if we do that and then pass that list here, so it should make a random choice now. Okay. So but the core idea is the same. Like we have to use random dot choice to get a number from the node's value randomly. Okay. Now, so somebody asked like, sir, show me the question. Uh, Show me the answers of question one and two. So the first one is this: web pages are the nodes and hyperlinks are the edges. And the second question was based on the page rank algorithm in a directed network. So correct answer was a random node which A is pointing to. So let's say, so if you didn't understood this question, this means like, let's say you are here. This is called A, and there are other nodes A, B, and C. So what is a directed network? Directed network means there should be arrows coming in or going out. So this is a directed network. So you see here what at this node, arrow is coming in from this node B or this node is C. Okay. So now so it is saying like if you are here at node A, now there are two choices in front of you. You can go to either node B or node C. So here it is saying like in page rank algorithm on a directed network, we randomly move from a node to other node by this choice. Because we have made a random choice, but we move from one to another in 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 that direction only, from which like the current node we are there to some other node that it is pointing to. So A is currently pointing to B and C. So we can only move either to B or C. But if you are, let's say, at the node C, so you see it is not pointing to any other node. So you can't move from here. But if you are C at this node B, so you can only move to C, but not to A. Okay, in the directed network. Okay, the next question is okay. The next question is the function network x dot page rank, and inside that we have passed graph G returns. Okay, so what is a page rank? So page rank is something like there is a node and then there is a associated weight with that node. Like how many, it depends on how many arrows are coming to that node, or so it is based on that. Now, if you say, okay, so now let's say if you have a network where some nodes are connected with each other, and then you run a page rank algorithm. So what will happen? So each node has some weight depending on the whether arrows are coming in or going out. Okay, so now each node should have some weight. So that's why this there is this page rank function which gives us the corresponding node and the corresponding value. I can show you one example here. So here, okay, we have a directed graph. Okay, so here you see we have a directed graph. No, no, we have a just a simple graph, and if we run this like okay, here you see we have this directed graph, but no, not directed graph, it's just simple graph. Now, now what we can do, we can run this, and it will add 5 nodes. And okay, now it will add 6 nodes because we are also including the six here. So if you print the g dot node, so it will have a 6 node. Now, if you print an x dot page rank, so what will happen? Each page has some rank. So it is like this, some different number. Okay. So it depends on the fact like how many arrows are coming in or going out. So it is like that. But the correct thing is like it's a dictionary. So there is a key, there is a value. So there is a key, there is a value. So output of this page rank is dictionary. So option C is correct. And now the next question is which of the following function is used to make a directed graph? So I think it should be pretty straightforward if if somebody has fully gone through this network X library. Like, and also in previous session, I have also told you about this directed graph. Yes, it's option A, and we can see it very easily. Let me show you. So let us import the import network tags as NF, then import uh, that's it. Let us create a graph, and that will be not a ordinary graph, but a uh, it's a directed graph, right? So the G graph, and then we can add more from add more from this function. Then we can pass a list one, two, four, then five. Okay, then we can add G add edges from, and then we have nothing but inside a list we are going to give a tuple as an input because we know that like pages should be pages will all be made from two inputs and then 3 to 4 and then 4 to 5 and then 5 to 6 and we are going to print no or no we are going to print. So if you see there is this arrow that is going from the okay let's do this one. It has no object attribute item. Okay, we can let's go to spider. Okay, how many of you like run your codes on Google Colab? More? Yes, Safikala, you want to ask something?
Yes, sir.
Yes, you can ask.
Um, in the assignments, while you are submitting the code,
Yes.
um, we need to check the reference, like any supporting video for that assignment is provided, sir.
For assignments,
Yes, sir.
like which big assignment you are talking about?
11th week, sir. 11th assignment.
Assignment number 7,
11th, sir.
11th. Oh.
Yes, sir.
So there is I think there is no reference video to solve any assignment because these assignment questions are new. They are made every year. So it is you guys that you have to solve the assignments, the assignment question.
Oh, okay.
Yeah. Okay. So let me share this one. I will share. What we are going to do, we are going to import a network X library. Then we will also create. So first, let me show you how a normal graph looks like. So it is nothing but annex the graph. Okay, and then we are going to add some nodes. So g dot add nodes from, and where we are going to add nodes from random list, and then we are going to draw. No, we will to add the edges. No? Add edges from, and then we are going to add it from list, and that contains tuples inside it. So because like edges need two values and tuples are good because we can't modify them. So five. Okay, this is it. So I will draw it. P comma this level. Okay, and we make it true. Now let's just see what is the output. So you see, if you see, uh, in it, so there are no errors, right? So because we have what we have written, it's just a simple graph. But what if we make it a DI graph, means directed graph? So you see, now there are arrows appearing where it is pointing from 1 to 2, 2 to 3, 3 to 4, 4 to 5, right? So this is what a normal graph, because no point, there is nothing going in or going out. And here something is going in or now, okay. Now you see there is the arrow 2, uh, there is an arrow between 2 and 3. Now we can create an arrow between 2 and 4 also. So that means we can give an age where It goes from 2 to 4. So you see 1, 2, and then 2 to 3, and then 2 to 4 also. So, but it's directed in nature. Like the arrow is coming from to 2 to 2, but it is going from uh, 2 to 4. Can we do the reverse? Can we do the 4 to 2? Yes. Now you see, it's bi-directional. This arrow, see this arrow between 4 and 2, bi-directional. That means that 2 is pointing to 4 and 4 is also pointing to 2. So this is what a means a directed graph look like. But if you make it like just normal graph, so there is nothing. No, you will not know like which graph it is pointing to, or like it is going from 1 to 4 5 and 1 2 3 4 5. Like you will not know like who is pointing to 4 or not, because if you remove this one like this age, I think, so what will happen in this one? There is no change in that graph. See this and this, but there is change in this one, in the directed graph, because there is only the arrows going out from 4 to 2, 2 to 4, but there is no arrow coming in. But if you put that value back, so yeah, put that value back here, so you will see that arrows are coming from 2 to 4 and 4. Okay. Yeah, I knew, but the thing like crashed. Okay, so option A is correct. It makes a directed graph. I hope like you have clearly understood what is a directed graph, right? It's different. So here the you have to specifically mention like whether the arrows will go from 4 to 2 or 2 to 4, and you have to write it there. You have to give the age in such a manner where in the tuple you will write 2 comma 4 or 4 comma 2 to get the edge from 2 to 4 in the directed graph. Okay, and then this one is the output g dot out edges, and then node name is a list of dictionary, list of list of vertices, list of tuples. So it means like if you have a directed graph, list of tuples. Okay, let us see. Like we have the directed graph now. So you know. So let us print that. Let us print for print. Okay, I should save my screen. Guys, let us print for g dot not g dot out agent. G dot out. We have to put the node name. Node is two. So you see, here, it's a two, three, and two. That means the edges that are leaving the node 2 is from 2 to 3, and it is from 3 to 4. But if you type, let's say, node 5, so what you expect, what you will get as the out edges? Can somebody answer? Mhm. I can. Sorry guys, but I really can't see my mouse arrow. Pointer is not see. But click it. But if we run it 2 comma 3, 3 comma 4. What happens if we do something like 5? So from here, from the graph, uh, from the graph, like 5 is isolated, and there is no edges going out from 5. So it should give us an empty. So as expected, it is giving us an empty list. Okay. Now let us check for the edge one. So there is only one edge that is going from 1 to 2, and it is from 1 to 2. So that's why it is there. But if you see again for 2, so you are not going to see any edge from 1 to 2, because it is for the out edges, like the edges that are leaving the particular node. Okay. And what is this? So it is a list of tuples, right? Because you have seen in the output, it was a tuple inside a list. So it makes sense because when you're talking about two edges, when you're talking about edges between two nodes, so you know for sure that this edge has this name and this edge has this name. So that's why you put it inside a tuple and they are not immutable, right? So that, and then all the information you can store in a list. That makes sense. Like it's your tuple. Then the next question is okay. So till now we have talked about how we can move from uh, one node to another node in a directed graph, and we then went on seeing how this directed graph works and how there are out edges in edges in the directed graph. So we also have seen the particular nodes have this much out edges, this much in edges, all these things. Okay. Now the thing is, so why we are doing that? So, so the logic behind doing all these things is to like understand how this page rank algorithm works. So let us say in this game, okay, because when you go from one web page to another, there is some weight factor is associated, like which page is referring to this page and how many pages are referring to this one. and those pages who are referring to this one, are they itself important? So in the, and then this referring to like this is calculated, some value is calculated, and then it is sorted, and then that is what called and then that value is sorted, and if it is uh, referred by most and most influential nodes, let's say, so it will appear at the top, and that is what happens here. So let us try to understand in this scenario. So let us say you have four nodes, okay, and as you can see, each node is referring to another node. Like one is referring to two, two is referring to three is referring to four. Okay. Now the question is, if initially I am giving 100 points, let's say, to each node, and you know the algorithm, like each neighbor, so whatever the value you have to share that value equally with each neighbor. This is the only criteria for this game. So let us say initially I have 100 coins for each of the nodes. So after after a, after a certain iteration, so what is going to happen in this game, in this scenario? Options are one node ends up having all the coins, and the game stops. The game stops after some iterations, but one node does not have all the coins. The game runs in an infinite loop, none of them. So Arun Kumar is saying like this option A is correct. So how many of you agree with Arun? Just answer it, don't hesitate. Maybe wrong, it may be right. Okay, okay. Any other? Okay. Just think about it, and then based on your understanding, just give the answer. So you know the rule. Like if you have 100 coins and you are connected, like I am directed towards you, so I am bound to give you 100 coins in each iteration, and all my coins will go to you, and your coins will go to your neighbor that you are pointing to, and then it will go goes like this. Okay, so okay, it's not so let us understand this. So let us say initially I have 100 coins at node one. I have 100 coins at node one. I have 100 coins at node three, and then 100 at. So what will happen at first iteration? Because the logic is you have whatever you have to share it equally with your neighbor. Okay? So my neighbor is two, and two's neighbor is three, and three's neighbor is four. So if when the first iteration will happen, t is equal to one. So what will happen to node one? Node one will have 0 coin because of what? Because it has given all the coin it has to node two. But node 2 will give us its point to node 3, and node 3 will give us its point to node 4. So, so the only thing it will receive from the other node is 100, and that is from 1. So in the first equation, it will have 100, then 3 will have also 100 coins, and then the 4 will have, because it is pointing towards nobody, so it will keep its 100 points, and whatever points it is getting from the, so it will have 100 plus 100 equal to 300. Now what will happen as t is equal to 2? So because it's 0 now, and it's 100, and it's 100. So from 0, it will give this to 0, so that means nothing. Now this one will give value to this one and will become 0. And this one will give its value to this one and remain 100 because it has got some value from this node 3. So at t is equal to 2, what will happen? Node 1 will have 0, node 2 will have 0, node 3 will have 100, node 4 will have 300. Now what will happen if we go for one more iteration? So now it's have 0, this have 0, this have 0. So now this will go to directly here and it will become 0. So now 1, 1, comma 2, comma 3, all these nodes will have 0, but node 4 will have 400, right? And there are no coins left, so this game will stop. So the option A will be correct. Does anybody have any confusion or question? If not, then the next question is the question number 8 is in the collage conjecture for the positive integer n, if n is even, what operation is applied to n? Does anybody remember if you have gone through this collage conjecture video or this week? I will be very happy if somebody replies. It's very simple. Yes, it's A, n by 2. So I think most of you have gone through this video, like. But anyway, so let me first brief you about this collage conjecture. What is that? And then we can have this. We can discuss this question. So here is that. So it's this few lines of code. So here what we are so here what we are trying to understand this one collage conjecture. So you have a number, and if that number is even, let's say if you have 8, so you will divide that number by 2. So you will have 4, and that is also even. So that you will divide it by 2, and then it will become 2, and then again you will divide it by 2, and it will become 2. So you will reach to 1. So the thing is like in collapse conjecture is you have any number and you have to apply a certain algorithm so that you will reach the number one after some number of operations. So like from reaching 8 to 2, 8 to 1, you perform 1, 2, and 3 of three number of operations, right? But what happens if a given number is odd? So let's say the given number is 3. So if it is 3, you can't divide it by 2. So what you can do is you can multiply it with 3 and then add 1. So it will become now what? It will become 10. Then you will ask again, okay, divided by, it's an even number divided by 2. So that means it will become 5. Now if you have 5, that's odd. So you will do, you will multiply and add 1. So it's a 15 and plus 1 is 16. Now it's even number. You will divide it by 2. It will become 8. Then divided by 2 becomes 4. Then divided by 2 becomes 2 and then 1. So the goal is like whatever number you give me, it should using this collapse conjecture, it should go to value 1. Okay, this is what we are doing. So the question is here, like if you have the positive uh, integer n and n is given, so what operation we should apply to n? So the correct answer is that we should divide it by 2. The next question is, what is the ultimate goal of the collapse conjecture? So as I have just shared, so uh, we just want to take a number and perform a certain algorithm till we reach the number one. Sir, please, previous question. So this is the previous question. Okay. So let us go here. So here, what we want to do is that our our aim is to reach a number one. If I give you any number, by performing this collapse conjecture algorithm, you should reach a number one. That's the only thing we are doing. Okay. Now, answer is B, obviously, because we want to reach a number one. So let us look at the code of this collapse conjecture. We share my screen and discuss that below. So what we are so what we do first, we have a number that is in this function. So, okay, now we have a number. Now, what we have to do, we have to check, we are checking here. If that number is even means its modulo division should be 0. If it is so, then perform then half it, like divided that number by 2. If it is not so, then what you do, you divide that number. Sorry, you don't divide it, you just multiply that number by 3 and then you add 1. And okay, so now this new number will go here in this condition where it will compare whether this number is 1 or not. Until we reach 1, this loop will continue. And in each time this operation happens, so the one is we have assigned. So each time this operation, whether this number is divided by 2 or this number is multiplied by 3 and added 1, this counter include value integer. Okay, so let us compile this function and now let's call this function. So this the function will return value number and how many times it took to reach value 1. So let us call this latch conjecture and we are going to give number 7. So, okay, so the number becomes 1 at last. You can see it here. But it took 17 steps to reach to a particular number. Means it took 17 steps to reach a, sorry, if we have already included that print statement, so no need to put this inside a print. That's why we are getting a number because there is nothing to print. Now, if we run this, so we are getting what? We are getting 1 and 17. That means this number has become 1 and the step is to it's 17. So we can actually what we can do, we can print the number at each stage. So so we can see what is going on with that number. So first what happens? It's because it was 7 and it was odd number. So we multiplied it with 3, that is 21, and then we added 1, that is 22. Okay, now 22 is a even number. So what you do, you divide it by 2. Okay, so 11 now, but it's odd number. So you what you do, you multiply by 3 and add 1. So 33 plus 1 is 34, but it's even. You divide it, it becomes 17. Then you do this multiplication of 3, then 1, and then or and so on. And once it reaches to 40, so it's just 40, it's a even, 20 even, 10 even, 5 odd, but 16 is even. After that, the multiplication with 3 and adding 1, and so on. Let us see for the value 3 also. So the because the 3 was an odd number, so let's say print 3. Let's print the number. Okay, the number was 3. It was odd. That's why 3n plus 1 means that 339 plus 1 is 10. And then after that, okay, we have got 10. Now what you do, you add 10 each even number divided by 2. That's odd number 5, and then multiply by 3. It's 15 plus 1 is 16, and then that's even number, then divide by 2, even number, then divided by 2, even number, and so on. It reaches up to 1. At last, it took 8 steps to reach at 1. So it's like that. So here for 17, for 7, it took around 17 steps. Let us see for what happens if we put number is equal to 256. That is just so what happens to 56 is odd even even number, 128 is half is even number, 64 is half is even number, 32 is half is even number, 16, 8, 4, 2, and then 1. So it took around it took around 9 steps. And let us print one more thing. Let us print 2 to the power 9 and compare it. Okay, so let's make it cheaper because there should be no initial power. 2 to the power 8. So you see, it exactly because it was the here is something kind of very intuitive. Like you know that 256 is just a 2 to power 8, right? So if you just and if you divide it by 2, it will give you the even number means because it's a multiple of 2. So this will happen exactly 8 times, right? Till it reaches 1. And that's why if you print 2 to the power 8, so you get that same number, 256. Okay. So does anybody have any question in this Collat's one? Collat's conjecture? I think like this one, this how many times if some given number is a uh, it's it's like 2 to the power something, it's equal to some number. So this this Collat conjecture will take exactly that power. So whatever that power, it will take exactly that step only to reach to one. Okay. So the next question is, in the context of page rank, what is a damping factor? So a factor that determines the edge of a page. Sorry, the context of page rank, what is a damping factor? So a factor that determines the age of a web page, a factor that is used to penalize overly long documents, a factor that represents the likelihood of a user clicking on the link, a factor that measures the speed of a web server. So I am thinking like from the options, very obvious, like which option should be the correct option. Can you guess one? So it's option number three. Uh, so it's actually a factor that represents the likelihood of a user clicking on a link. So you know, like web pages are nothing but they are just a hyperlinked text. It's very simple, I think, if you try to understand it. So you have must have seen the PDF documents with a hyperlink in them, right? So think it like this: like you have a one document, this is one web page, and you hyperlink this page with this hyperlink, and they are connected like this. So and you read all the things that are here, and then you click on this and you reach this web page and so on. Okay. The next question is, which of the following factors does PageRank consider in ranking web pages? So I think we have already talked about this. So it's a page load time, font size and type, keyword density, inbound link quality and quantity. So those who have gone through the lectures, can you give me an answer for this? If you don't know, just guess what is the most, what you think is the most suitable answer for this. Yes, Yasir Agrawal is C, and Newton decides C or D. Okay, that's good. So I think I'm getting more on D, right? And others, what do you think? Okay, okay. So the correct answer is why it is that? Because so so defining while defining the page rank, the only criteria we consider is the how many links are pointing to you, means pointing to your node, and other thing is who are pointing to you, means are they are very popular or what. So that way uh, the page rank is defined for ranking the pages. So it's kind of popular. People are making a friend group where they point to one another and they all get popular like that. Okay, but the number of quantity is also also matters. Like how many pages are pointing to. Okay, next question is, what is a drunkard walk? So this is a very interesting question. Those who have, I think, learned about statistical mechanics or statistical physics, they know what this is. Or they, they know about statistics in general, if they have taken that course. So why it is called a drunkard's walk? So suppose, not suppose, think a scenario where someone is so drunk and he's not a he has lost control of his senses. So he don't know whether he's walking forward or backward or going this or that. Now, if you ask him to go somewhere, so he may take two steps forward, one step backward, or two step backward, one step forward, and so on. So, so that's why the name Trunkers. So, what do you think? How? What is the pattern of that guy? Like of that step? What is the pattern? Whether it's maybe zigzag. Let us say it's one dimensional. So it's one dimensional. So you are only bounded to move either forward or backward. So what do you think? What it will happen? Yeah. So strategize walk. And why, guys, like why you think like it will be strategized walk? So that okay. Think about that man who is so drunk that he don't know what he's doing, whether he's going forward or backward. So where is the strategy? I don't see any strategy in this. It's just drunk. He don't know anything. So it's whatever he will do, either going forward or backward, is just random. So that's why this called the drunkard's walk, because it's a random choice. He's making and going either going forward or backward. Okay, so it's another name of a random walking. Think about it and read about this random walking. So you will see, if you know about this, uh, because I think if you go for a large number of this n, then whatever the distribution that comes is a Gaussian distribution. That means it's they have a central. Okay, here in the middle you have started. So probability of being uh, of you here and probability of being of you at the right and left hand side. So it makes a Gaussian kind of curve. So it remains very sharp, not very short, but it has the highest probability at the origin, like where you started, and then it decreases the distance from that equation in both hand sides, like e to power minus x squared type. So it's a random walking. Yes, Adhira. Yes, it's random walking. But don't try it, huh? Okay, the next question. This is very simple, I think. The number of gold points in a gold point distribution game keeps increasing in every subsequent iteration, keeps decreasing in every subsequent iteration, keeps varying randomly in subsequent iterations, remains constant. So what's the correct answer? efficiency vary randomly in subsequent iteration. Okay, so I'm talking about the total number of gold coins. Sorry guys, this is for the number of gold coins in a gold coin distribution. It means like total number of the gold. Yes, because we have just seen the example, so it's option D, where all the okay, whether one node has 0 and one node had 100, second node has 100, then this node has 200. But all the summation of all the gold coins were constant, like it's like energy, right? You can't destroy energy nor create it. You can just use it. So it's like energy. It can't be created or it can't be destroyed. Okay. So yes, it remains constant. So distribution changes, obviously, yes. That's why it's called distribution. But the gold coins, it remains same. Okay. Okay. Then I think that's for it. Does anybody have any question? Does anybody have any questions from the previous class or previous sessions? Some from assignments, anything we can discuss. If we didn't get your the solution, we can discuss later on, or we can discuss it tomorrow. So I'm going to take a 1 hour session tomorrow. So where what I will do, uh, I will like it will be a revision kind of a session. So I will revise all the syllabus that was there so that you guys can prepare uh, for your exams. Okay. So before that, okay, so it will be good if you guys can ask me questions. So like beforehand, and I can make some notes or something to like so I can tell you more about that question, not just the answer like other. So I can tell you in details. That session will be from tomorrow from 6 to 7 p.m. Sir, can you tell me the question pattern of the exam and important questions? Sorry, but I don't have any idea about how this question will be there. Okay, maybe you can ask this one in that forum. So the people who are there running this course, the NPTEL people, they may tell you what is the like what is the pattern of that paper is. Okay, guys, like if you have any doubt in the other sessions, like or any topic that we have been through, so you can ask. So B12 Q2 assignment. Okay, B12 assignment Q2. Assignment. The question two. The programming assignment or what? Let us check. Uh, quiz two. Which Rated social network graph what might the latest engine. So, I think it will be all of them because it makes sense. So in the matrix of full network now, yeah, I think it's will be available. So what are like your so what does anybody think differently about this question? The question number two. I'm confused for T option. The time of interaction between users. Yeah, I think I'll say all of that. So the time interaction between users, what does it mean? It means like a user. Okay, so I have like let's say I have two web pages, and they are connected through an edge. So like a hyperlink. So I'm clicking this hyperlink to go here, and then clicking this hyperlink to go here. So somehow it is making it a biased kind of network, right? So, so how long I am going to be there in this website, like in this one, but if there are other nodes also, so it will matter. But if this is the question, like we can discuss it tomorrow and in great detail. I'm taking notes. Is there other question? So if you have the, other question, like from anywhere, any like from any other session, because I need some question to discuss with you guys tomorrow. Otherwise, like I will just revise whatever was there in the like in the course content. Maybe if does anybody have any doubt in this session? Because we have half an hour to discuss. We can discuss anything. Sir, week 11 assignment. And what is that in that assignment? Maybe you can uh, tell me the question, like what is all the programming. Uh, be honest, is that code like the assignment date has gone or it's there? Like you have to still you have time to submit. If you have time to submit, then I can only talk about like similar questions, not exactly the same question, but I'm very sure like you will get an idea how to solve your assignments on it. I will try to make a similar question so you can okay. Yes, I will do that. Yes, obviously. So I will I will make a similar question for the 11 assignment and then Ganchari money. Kanta Reddy is asking, sir, can you provide a short note on all the benefit of all the bigs? Yes, I am going to do that. I am thinking about sharing a Google Collaboratory notebook where I will put all the Python codes that we have done till now. Means like I started sharing this Google Colab notebook, I think from week 6 or 7. But before that, I have in the important code in my offline repository. So what I'm going to do, I'm going to paste in all the code in one, like by big white, and then I will share it with you. Sir, T is becoming a bit difficult to find the output if the code is repeated. Sir, it is becoming a bit difficult. Okay, I will say that. And okay, so you guys can okay that and you guys can subscribe to my YouTube channel. So because I am going to upload, I think I'm thinking about uploading a series on Arduino's. Like so, those who are interested in Arduino, maybe you will have a lot of videos in the coming days. It will allow you not to cope up with the code that has been shared in the video. In the videos means NPTEL videos or in my videos. Okay. Uh, okay. So what I think this NPTEL the guys are doing like the bigger course like for I think when I myself faced this when I was learning about this random library, right? So where they have done some simulation regarding this dice, and then there they made some games and all. Okay, so the yeah, snakes and ladders. So I think that program was a bit tedious. But what they're trying to say is actually it's it's because they know Python very well and they understand the underlying concepts. Okay, so they were trying to show, oh, this can be done using Python. But if you see your assignment questions, they are not like that. They are not that much different. They're different, but not that. So they are just giving you an idea. They are just scratching your mind. Okay, this can be done. So you feel motivated. You do a bigger problem than that also. But you know now if you learn about those problems that they share in this NPTEL video, so it gives you confidence. Like yes, they are difficult. I agree. Like today itself, if you in this big 12 itself, if you see the code for finding this page rank, okay, so it's difficult. Okay, Sam, can you share your YouTube channel link or the name? So okay, let me send that. Okay, here is my here is my website link. So here you can find all the contacts, contact details related to me, like my YouTube channel, my LinkedIn profile, my email address, all the things. Okay. So, so how many of you are learning this Python and want to go in research? Anybody? Okay, so all of you are learning for this data science or kind of computer science engineering background, right? Uh, that- yes, Safikala, what is, do you have any question? So you typed yes, sir. I didn't. It's like you are agreeing with the fact that you are doing it for computer science engineering. Okay, mm, I, I think you wanted to say that only. So what is the answer of question 3 and 4? That's good. That would be good. So, Nutan Gupta, you are saying like, what is the answer of question 3 and 4? Are you asking about in this session itself? So let us go to question 3 and 4. So the question is, yes. So the answer is this random.choice g.node. Uh, so this one is there, and the 4 is page rank. It returns a dictionary. So that I showed you. So what exactly do you do in data science? Safikala, can you like give us a brief idea to me, like to anybody who is present here? What is this thing like you guys learn in data science? I have like I have like no idea what you do in the data science. We have a time we can discuss all like if you don't feel comfortable, it's okay. But if you think you can say it, then you can type deals with huge data like Camel database or business analytics. Okay. So is there you are like doing very much of kind of analysis of is there very much of statistics involved? Okay, I see. Uh, so may I know where are you guys are from? Just type your state name, like you are from there. Like so, I have idea. I can have idea where are my audience from. So it means Andhra Pradesh. I'm coming on. Wow, all over from India. Yeah, nice to see Hyderabad. Wow, nice. So it's it like all of you are learning this one for the first time, like this Python programming, or you have learned it by yourself and then you thought, okay, we should do a course on it. Oh, self-learning. That's good. It should be appreciated. I like self-learning is so much important because when you are learning by yourself, so what you are doing, you are training to deal with the problems that comes not only in your code but in your life also. So that's good, and you know how to cope with that pressure. Right, good. Okay. So how what do you think? How was the course? You can just type good, better. Like it can be better if you like. For me, can you tell me uh, what are the what was the what are the good points that you liked about my sessions on what are the bad points where I can improve? Just type it. So I can improve in the next sessions and I can keep those things which are good for like next NPTEL courses, all of that. So it matters if you guys can do this, give me some feedback. Okay, I think nobody is comfortable in writing good or bad. Just write good. Okay. Okay. But I would really appreciate if you have any questions so that you can ask so that I can give you the answers in the next session. Any doubts that you want to clarify? No, no doubts. So, okay. Uh, nice one, huh? If you can give answer to 12-week assignments if you want. I can make similar problems to discuss in the next session in week 12. I can do that. Like I can discuss the similar problem uh, which will give you an idea how to solve your assignment problem. Because I'm not allowed to solve your assignment problem. Okay. Uh, okay. Priyanshi, did your that Chrome driver problem was resolved or is still there? Who was that? Who mailed me regarding the problem? Okay. So I think okay. Okay. How many of you know how to run like this Python script from command line? I think there has been no introduction about the command line, right? Means you save a Python file somewhere, then you try to compile it in using like in the command line, and then You are getting some output of all these things. No? Okay. Are you interested? Like I can give you some basic commands or like how you can do that using the command line. Like using your okay. Yeah. So, like till now, so I have seen one thing, and that was very common. Not common, but like many people, you guys don't know how to, or you maybe you know, maybe I don't know. But the thing is, like changing, going from one directory to other directory, and then locating your file by not touching your mouse, just by doing all the thing in the command line, the command prompt and then compiling the code and then getting the output, all these things. So it creates a like lot of problem for many many of you. Like when I was learning this thing, like learning this Python or any other language, like I was very confused. Oh, what is this? Why I'm doing this cd and then giving some directory name? How it is working? I don't understand this. So I thought like maybe I can share something for that also. So I will write few things like I will introduce you with the basic, very basic command in the command line just for your convenience because it is not going to come in your exam. Just so that you can have a proper understanding of how you can do that from the command line. Also. Okay. And did you guys understood how this packages works in Python? Like, what are the packages that you just import? Oh, from pip import this thing, and then you just use it without knowing what is going on behind them. Like, what are those things that we are importing? Can we do something with like can we write some function and which we can import in a different uh, Python code, like if you have written, let's say hello.py, this is one code. Can we call this hello.py in different Python code? So think about it. Yeah. And then there is also like environment variables, and those are like a real thing. So it creates a lot of problem when you are trying to install a package and then that package gets corrupted or something, then you have to uninstall it and then all those things. Then you have to deal with the environment variable, then path, then all other things. Okay, so I think I will make a very short. I will give you very short uh, explanation about this thing tomorrow. So don't forget, like tomorrow we are going to have a session from 6 to 7 p.m. Okay. Okay. So, touch anybody have any other questions, suggestions, anything? Okay. So I think then we can stop here. Okay, guys, then bye. We'll see you tomorrow. So I'm going to end this meeting.